All right, so we're going to get started today with exercise 217. This is kind of the last piece of the puzzle of the skyscraper that we've been working with. So the last two lectures we talked about the environment and the V-Ray renderings and that sort of thing. The good news for you guys is you'll have a little bit of extra time today, assuming these things go easy, which I'm speculating that they will, to work on your assignment and start to get ready for your assignment. You will, as part of your assignment, have to do the things that we're doing today. So this is definitely part of it. I have a 3D print running, another test of the 3D printing and whatever. It's taking longer than I anticipated, so I'm working through those kinks still. But once it's done 3D printing, it should be done in the next hour or so. I'll bring it over and you guys can see that as an example model. But today we're going to talk about how do we get this model, this skyscraper, into a form that we can make. And I'll go into my office and grab a few of the unrolled surface models so that you can see what they were. I used to require that they actually make the unrolled surface models. But there's two different ways that we can make these buildings. The first one is by kind of like the way that you guys in 130 had the shapes that you would fold flat and cut out and then glue together with the little tabs. We can do the same thing in Rhino. Rhino has a command that allows us to do that. And so I'm going to show you that, and we're going to walk through that. And you will ultimately today create a model that you could walk over to the laser cutter, cut out, and glue together. You don't have to do that as part of the class. But the second half, under part 2 of what we're doing today, is that you need to figure out how to create a model that can be 3D printed. And so I told you we were going to try to wrap in 3D printing. So today's going to be the day where we talk through how do you make this model in the first place and get it ready to 3D print. So I'm really going to set up two different parts to this. The first part is these unrolled surfaces, and the second part is the 3D printing. Remember what I said last time about if your building has a bulge, if it has anything that looks like an egg or something that has curvature in two directions, the unrolling the surfaces isn't going to be possible. If it is challenging, then we'll simplify your building so you can do an unroll of it. Obviously, when we go to 3D print, it's really easy. You can print anything. It doesn't matter if it has a bulge in it or not. So the truth is, if you were going to make the building in real life, making something with a bulge in it is much more challenging than making something without the bulge in it. So what I've done is I've gone back and I've opened up the file that has just my building in it, because I'm just going to work with my building for just a second, because I don't need all of the city of San Francisco or all of those kinds of things anymore, because I'm talking about making a physical model out of this particular building. So I've done that, and before I move on, I'm going to do a save as to make sure I have a second copy of it, and I'll actually save it to today's folder instead. We're on 217 here. And then I'll click save. I do apologize. My voice is starting to get worse because I've been talking. The smoke is actually affecting my talking in here, even though we're inside. I can tell I'm getting, and of course I lectured for 2 hours in the morning class. You know, it has to go that way, right? So if my voice starts to get a little scratchy, I apologize in advance. So anyway, we have this file. I've saved it as so that I can work with it. The first piece of the puzzle here is we really don't need the floors and the ceilings anymore. So I'm going to turn those off for now. I may come back and turn them on a little bit later so I can show you an extra step that you can do that may or may not be useful to you. But ultimately, what we're working on is this outer shape. That's what we want to be able to cut out. And so the first thing that I need to make sure is I need to make sure that this shape is joined together into a closed polygon. So if your shape has a bunch of individual pieces like this, you're going to want to make sure you take all those pieces and join them together. The hope is that they come together rather nicely. So I'll take those pieces, I'll type join, and they do come into a nice joined polysurface. At this point, I want to be able to unroll these flat. And in my example here, these are all straight lines, so it makes it relatively easy. There's a little bit of a twist to it, but it'll unroll rather nicely. And to do it, I'm going to use a command called Unroll Surface. It's available. You guys can see the tutorial on Rhino 5.22. So I've walked through that process. It's as simple as typing unroll srf. You can also go into curve from objects, And I think it's listed there as an unroll surface. I never access it this way. Maybe it's under surface. Unroll developable surface. There it is. Sorry, I never go into the menu to do it. But that's where it is if you want to do it that way. Unroll SRF. And we're going to look here at the command line. It says select the surface or polysurface to unroll. So it's ultimately going to be this surface. That's good. But there are some options that are available to us here. The first thing is, do we want to explode the shape or not? Generally speaking, if you set explode to yes, it's going to take more work to reassemble it, but you're not going to have any overlapping pieces. If you have it set to no, some of the pieces are going to overlap, and you're going to have to untangle those pieces anyway when you go to cut it out. So I tend to leave it set to yes. The other thing is labels. Do you want them to be on or off? It's really hard to figure out what shapes match up with what without the labels. So I would definitely turn the labels on. So you want labels to say yes. And the keep properties as no is just fine. Before I actually finish this, though, I am going to create a new layer so that I can put my shape onto that layer. It just keeps the organization a little bit better. So there it is. I'll go ahead and hit enter. And when I do that, you'll see that Rhino labels my model with a bunch of numbers. And it gives me a bunch of pieces that have been folded flat for me. So it takes them and it unkinks them. And it doesn't matter that these pieces twist because it's basically laid them flat. So in this case, it's a matter of going through and kind of reassembling the pieces. And it's nice to have the numbers because you can reference, OK, what goes with what. So in this particular example, this piece would be the top. So let me pull this off to the side here. And you can do this if it helps. You could do this in the actual top view. Pull that off to the side. And then I'm looking for, let's say, piece 1. So there's piece 1. I'm going to move piece 1 so that those match up. Then I'll rotate around, and it goes there. So in this instance, see how this overlaps with that? It's probably not going to line up particularly nicely there. So I'm going to leave it there for right now. I'm going to go find piece 0 and see if I can start to line these pieces up a little bit differently. Rotate. All right, piece 0 has no problem. That's fine. It's possible that I can line up side 35 with side 35. I don't know yet. So I'll try rotate, and we'll see if I can line this one up. With that piece. So it's close, but that little gap's going to present a problem. So I'm going to leave this piece here for now still. Still not quite doing what I want it to do. Let me take piece 2, and we'll move this one and line it up with piece 2 here. Let me rotate piece 2 so that goes there. So it works fine against piece 1, but it collides with piece 0. So you can see how this starts to get complicated. In this particular shape, and I haven't ever done this shape before, I may have to do 2 separate pieces that come together. I don't know yet. So we'll see as we go along. So let me do the big outside pieces first. Let me do 9 and 6. That one. 9. And what was I on? 3. This conveniently didn't quite line up. There we go. So there's there. Now I do have the bottom of this shape, so I can take the bottom and I can drop the bottom over and connect it to 18 here. Like that, for example. And then I can start to work my way backwards. So 20. There's 20. Not sure if that's going to work there. Okay, that works, but it's overlapping there. I could try it on piece 8 on the opposite side and see if it works better on piece 8. Okay, it works on piece 8. They don't collide there, so that one will work. Piece 19, we can try moving that one. So the point is that this takes a little bit of time to go through and organize such that they don't collide and that as many of the pieces as possible go together. So that one didn't quite work, so 7 didn't work. So I'm going to have to spend a little bit more time. Obviously, the piece that I picked ended up being a little bit more complicated. So let me do another example that's a little bit simpler for you. I'll do a quick model over here, and we'll do that. Do another piece here. Let's go at 100 feet. And it's 600 feet. Yeah, let's do. There we go. Let me take this piece and cage edit. Bounding walks, world, 2, 2, we'll do 3. All right, there we go. Let me take this. And we'll rotate. OK, so there it has a little piece to it. I can unroll this surface as well, and this one will assemble a little bit easier. So there it is. I can do unroll surface. There's my pieces. Select. My options are the same. This, unfortunately, put the pieces right on top of the other pieces. So let me back up for a second there. Let me move these so that they're out of the way, and then I'll do this one. Unroll surface. My options are still set. Explode, yes. Labels, yes. Keep properties, no. I'll hit enter. I have fewer pieces this time. So there's my various pieces. And now I can actually start to assemble this. So in this case, this one's a little bit easier. Here you go. Kristen. I'll line that up. I'll do rotate. There it is. 7. No, the core won't be there. All right. So that one was a little bit more simple. So I was able to lay that out. And if I were to cut this piece out and glue it together, this would make up my model. And it's actually pretty neat. And I'll bring some of the examples so you can see them. But when you glue it together, it will naturally start to twist, assuming you line it up, and you'll get that shape out of it. It's pretty fun. But if I think about cutting this out, this isn't ready to laser cut just yet. And so I need to actually prep this file completely. If I'm going to do that, I need to have 2 layers. So we'll start with a new main layer here called lasercut. This should sound familiar. We're going to create a sublayer for cut and another sublayer for engrave. If I can type. Now this, having the red and blue lines, is part of your required work as assignment 103 or 203. So you do have to make sure it has the red and blue lines as if you were going to walk over and cut it out. So you don't actually have to do it, but I want you to make sure you're ready to do it. So I have the laser cut layer. I have the cut and the engrave lines. So let's start with the engrave layer being active. I'll make that color blue. And I guess while I'm here, I'll make the cut layer red. OK, and I'm going to duplicate the edge. So dupe edge, which is also available under curve, curve from objects, duplicate edge. And this will allow me to go through and pick the edges as I go around my object. We'll do that. I also want to pick the fold lines. So if I have a surface edge, I want to make sure that I pick those, because this is going to be engraved. I'll pick these edges, there, there, there. So now I have all of those. I'll hit enter, and it will make a bunch of engraved lines. So there they all are. You can see them as blue. If I were going to glue these together, though, it would really help if I had some little tabs, something that could fold and glue. So wherever there's an adjacent side, so if I look at 1 and 1 here, one of those two should have a tab. So I'm going to do an offset, and my offset distance needs to be something that's kind of appropriate in size for a tab. I haven't scaled this object down yet, so I can't do it at 1/8 of an inch. I just want some distance that's about right. So I can arbitrarily pick what I think the distance should be, about like that. Maybe that one's a little bit fat. But I also only need this on one of the ones. I don't need 2 tabs. I just need 1. So I'll have it on that side, and it'll match up with 1. If I look at 6, I could do a tab for 6. Come on. There's 6, but I don't need one over here at 6. If I do one here at 9, for example, I don't need one at this end for 9. So you just want to make sure it's on one side or the other. There it is there. Need a few more here. There. 8 and 8, 5 and 5, 3, 1. OK, that's good. I need one for 11. So I'll put one there for 11. And I think I'm good on all of my pieces. So I just want to make sure that that's like that. Now these obviously are going to be cut lines. So I have to make sure that they change over to the red layer. So let me select those. Perfect. And I'm going to change those to the red layer. There they are. There's a few points, like here, this just floats in space. I'm going to clean things up a little bit. So let me make the cut layer active, and I'm going to draw a few extra little lines, imagining these as tabs that would help me glue my model together. So there on that one, I really should just trim that. Trim. Right there, because it ends there. Same thing here. This is almost spot on, so I'm not going to worry about it. A few more here. It looks like my rotation isn't quite right on these. My mistake. They should be right there. OK, so now I have these done. If I were to turn off the surfaces and look at this as a lasercut file, we're getting there. But there's some more things that need to be cut lines. This line, for example, needs to be a cut line because I need to be able to cut out my whole object. So now that I've gone through this and I've created my tabs, I need to make sure that the rest of the pieces that need to be cut out are in fact cut out. So that needs to be cut out, that needs to be cut out, that needs to be cut out. These three obviously need to be cut out. And that piece needs to be cut out. The rest of these stay as engraved lines. So I'll switch these over, change object layer, and now those are ready to be cut out. So essentially what I've created here is the cut file to take over to the laser cutter. If I took this over, even if it was just paper, I could cut it out and glue it together, and I would get the curving building that is designed, I don't know, way over here. I would get this shape right there with the little curves to it. So that's relatively easy to go through. The unroll process, Rhino does all the work for you, so it's not bad. There is an extra option that's built into this. So if I had a second copy of this polysurface here, come over here, let me move this away. In terms of posting this work, you're going to do an image capture of this file with your red and your blue lines, so I can reference your red and blue lines and know that you did it. But I have another option. And in this example, I'm going to put the floors back in. And I'm using the simple one here, so bear with me while I create the floors really fast. Let's array. And for clarity purposes, I'm just going to do one set of things here. So let me copy this vertical first. And then I'll array 1, 1, and 50. And it's going to be at 16 feet. That direction, perfect. Commit to it. Trim. So I'm only doing the floors. I'm not doing the ceilings in this example. Okay, so I have all of those floors that are put in place, and really these should all be on the skyscraper layer. So let me just change them. And before I do the unroll, I want the edges of all those floors. So I'll take this whole set of objects, and I'll go to curve, curve from objects, intersect, or intersection. And it'll give me a bunch of curves around the outsides of all of those floors. Rather easy. Let me put those on their own layer. I'll call these floor outlines. Change object layer. That's just to make selecting them easy. Now when I do the unroll surface, it says select surface or polysurface to unroll, right? And the rest of these options are still the same. So there, oops, no. There it is. And then the next thing that it says is select curves on polysurface to unroll. So the first thing is unrolling the surface, but I can also select any curves that are on this surface at the same time. So let me select all of those floor outlines. There they are. And now when I go ahead and do the unroll, okay, there's my numbers, there's all of my pieces. But as I look at this, hold on a second here, there are a bunch of individual little curves that represent each floor that were unrolled with the surfaces. So I could use all of those pieces as score lines to represent all the floors in my building. So let me deselect the surfaces for just a second so you can see all of them. There we go. There's all those floors. I could change those onto the engrave layer so you can see them a little bit better. There they are as the blue lines. And those then represent, if I were taking it over to the laser cutter, all the individual little floors, which when I look at my model would help me to visualize, oh, this is how big the building is, this is where all the floors are, and that sort of thing. So it's optional. You don't have to do this as part of your assignment or as part of today's exercise, but I would encourage you to think about it because it can really enhance the final output. And I'll show you some examples on the physical models that come out of this long term. So in this instance, I have those floors. I could reassemble the pieces. You guys don't need to watch me reassemble the pieces. I don't even know where I put them there. You can assume that those lines would line up exactly the same with the numbers, etc. So we've gone through part one in how we're unrolling the surfaces and we're prepping the file to go over and laser cut. The second half of this, oh, and by the way, what you're posting today is going to be the screen capture of this file with the red and the blue lines. That's what you're posting for your reference. You're not going to post anything for part two. But the second part of this is how do we create a model that can be 3D printed? And I think the number one mistake that people make when they think, oh, I'll just 3D print my model, is they assume they can take their whole model, you know, the one that they did the renderings from, and drop it into the 3D printer, and the 3D printer is going to spit out the model, right? Unfortunately, 3D printers don't really work that way. They don't like that. So what you need to think about when you're getting ready for 3D printing is, what is the outer surface of whatever you're going to print? What makes up that piece that you're going to print? And how can I best represent that? So in the case of my building, if we go back here to the building itself, and actually, you know what? Let me just close this file for now, and I'll make a second copy of that file for the 3D print. You can if you want, but all I need is a record that you did the red and the blue lines. That's the part that I care about for today. All right, so for clarity, I'm getting back to this point where I have my building. I'm going to go to File and Save As. And again, this is going to be a destructive process. So I'm going to end up messing with things because I'll delete pieces and whatever. So we'll save it back into today's folder. What are we on? 217. By the way, you guys are more than halfway through the semester, for whatever it's worth. It probably means it's midterm time, so you're all stressed out anyway. So let's do 17-3 here. And I'll click Save. So in the interest of kind of exploring what's going on here, as I look at this particular model, I have obviously the outer skin of the building, and then I have all of these individual little floors that are representative of the building. If I were to take this over to 3D print, the 3D printer would have a really hard time with these floors because they're not closed, watertight objects. That's what it likes. So all I really care about in this instance is, what is the outermost shell of the building? So all of these floors, I can delete them. I can make them go away. If you have other pieces that are part of your building, you can make those go away. We're really trying to simplify here into what is the outermost shell that we're going to print. One of the things that we need to do when we go through this, and this is, by the way, I don't have a tutorial because this is all new, so I wrote it into the exercise for what we're doing. One of the things that we can start with is a command called show edges. And this is a way of determining, is our model actually good? And so let me, in the interest of explaining things here, I'm going to explode my closed poly surface, and I'm going to delete one of these surfaces just so that it's not there, so you can see what happens. Okay, so right now, if I were to type in show edges, it's going to say select surfaces and poly surfaces to display edges on. So I'll select everything. I can type all or just select everything, and I'll hit enter. And it brings up this little floating menu here that says edge analysis. Show all edges, show naked edges, show non-manifold edges. What we care about is called naked edges. This naked edges will tell us what is wrong in our object when we're going to 3D print. So in this instance, I told you it wasn't going to like all of the floors. So the floors are a problem. So let me go ahead and get rid of the floors for right now. I'll just turn off the floors and the ceiling. Notice that all of those go away nicely. Okay, so that's good. We got rid of a bunch of problems, but we still have problems on all these sides. Well, if I took all of these sides and I said, let's join them together, and we looked at it, okay, well, that solved all of these sides because they're now joined closed lines or closed surfaces. So that's good. But it's also highlighting, oh, I have a big problem happening right here. Okay? So in this instance, that's my big problem. I have naked edges on the side. So I need to fill in that with a surface of some kind. And I told you, obviously, I deleted this. I had it there. But I need to recreate that. So let me use duplicate edge, which we used earlier today, so that I can create an edge and an edge on either side. I'll hit enter. Then I'll type loft to loft those two pieces together. So now I have a surface that's there that matches up with these two edges. That's why I derived the geometry from the edges. I know that the edges are the same as the edges of my surface, as opposed to trying to draw it. Now I could take this closed poly surface, select this new gray surface, and type join. And when I go to show edges, I might have to re-show edges here. We'll select the surface. I'll hit enter. Notice that there's no naked edges left. So this object is now a 3D printable object, which is exactly what I want it to be. Inside this object, if I go to wireframe mode for just a second, it was hidden, but there is my elevator shaft. The elevator shaft has a naked edge on it. So that's a problem. So I can solve this in two ways. One, I'm not going to see inside the building, so I can get rid of the elevator shaft altogether. It doesn't make any difference for what I'm printing. So the easiest solution is just to say goodbye to it and move on. If, however, I left it in place, I could close it off with another surface. In which case, it would no longer have any naked edges on it. It would be a closed poly surface, and this would be okay to go print. The 3D printer isn't going to print this inside of the other surface. It's going to say, oh, it's inside the surface, I don't need to worry about it, I'm not going to print it. What 3D printers have a tendency to do is they focus on the, let me switch this back into shaded mode, they focus on the outermost surface of these objects. The inside it fills with a bunch of crisscross pieces to give it some structural rigidity, but it's not going to make it a solid object unless you tell it to make it a solid object. It wastes too much material. So we try to make it a little bit lighter in that context. So the fact that there's a hidden little piece inside here doesn't really make any difference for our work, except if it had a naked edge, in which case the 3D printer would say, I can't do this. So we have to make sure that there's no naked edges. The term for no naked edges is called watertight. And essentially the idea is that if I filled this shape with water, no water would leak out of it. That's why it's watertight. That's what we're looking for as part of this process. In this particular example, maybe I want there to be a little bit of a base, which I'm going to encourage you guys to put a little bit of a base on there. I'd like that base to be about 1/8 of an inch in its size. That's our kind of goal. It gives us a nice little substantial piece. At scale, the 1/8 of an inch is, I believe, 20 feet. So I'm going to go ahead and create another object here. We'll just do a box corner to corner that starts at this corner and works its way around to this corner, like that. And I'll do -20 feet. And that gives me a little base for it to rest on. Makes it a little bit more stable when we go to 3D print it. And remember, I can come back to my naked edges. So let me go to Show Edges. And let me say All to select all the objects. And there we go. I'm making sure that naked edges is on. And I still don't have any naked edges as part of that box. So even though it's a separate poly surface, it is a closed poly surface as well. So I don't need to worry about the fact that technically there's an intersection between the bottom of this poly surface and the top of this poly surface. The 3D printer will just get rid of that information. Does that make sense so far? So, but I have to make sure that it's a closed poly surface. That's the key part of this. So there it is. I have my little base on it. And at this point, I need to start scaling it down into its appropriate scale. Because right now, this is still full size. It's 808 feet tall. Or in this case, I think it's only the 600-foot one. In which case, it's still too tall to go 3D print. If I took this over to the 3D printer right now, or if I took the OBJ file from this, which I'll show you how to do in a second, over to the 3D printer, it would have to scale it down. And I'd have to do some math over there. So I'd rather get this really set up now before we move forward. So we're going to do a scale of this particular object. And I gave you some help. We're going to do it at 3/4 of an inch equals 100 feet in its scale, which means this object's about 6 inches tall-ish. Okay? I reserve the right to change that scale if it's taking too long to print. We'll shrink it down by half or something like that. I'm still figuring those pieces of this out. It's not going to change anything for what we're doing today. So if my skyscraper is 600 feet tall, ultimately I want to scale this down so it's 4.5 inches tall. If my skyscraper is 808 feet tall, it's going to be 6.03 inches tall. So I need to do a scale of this object. So it's not a scale 1D, it's not a scale 2D, it's a regular scale. I want the whole object down. So I'll type scale. My origin point, I'm going to go along the side here. I'll start right there at the base, and I'm going to go up to the top here so I know what the height is. I told you this particular building was 600 feet tall. So when I shrink it down, it's going to be 4.5 inches. and I'll go ahead and hit enter, and my object disappears. Remember, this is the same thing that happened when we did the laser cut. We just switched from a huge object to something small. So immediately Z, enter for zoom, followed by S for selected, enter. There it is again. It's also not a bad idea at this point to move the object back to 0, 0. It may have moved. So I'm going to do move. We'll go back from this point, 0, 0, 0, and then Z, enter, S for selected, enter. There we are, right back at the origin. This now is at the size that's appropriate for 3D printing, which is great. Unfortunately, the 3D printer doesn't like inches. So we need to convert the scale or the units of this drawing, not the scale anymore, the units of this drawing into millimeters, which is what the 3D printer likes. So at this point, we need to switch our oh, it looks like I'm doing this slightly out of order. We can do the mesh first. It doesn't really matter whether I switch the units or not. But in this case, since I'm already on this track, I want to switch the units. I'll go to where it says inches down here on the right. We've done this before. I'll right-click on it, and I'll say Unit Settings. And I'm going to switch the model units from inches to millimeters. And when I do that, and I say OK, it's going to pop up something. Do you want to scale the model by 25.4? This is going to scale it and convert it from the inch units into the millimeter units. You want to say yes. And then we'll zoom select it again. There it is in millimeters. If you measure it, if I went to distance, and I said from here to there, it's 114.30 millimeters. I could look up what is, in Google or whatever, 114.30. Yep. Guess what? It's exactly 4.5 inches. So I did it correctly. I confirmed that I did it correctly, and I'm happy. This is exactly the units that we want for going over and 3D printing it. OK, so now that I have the unit set up correctly, there's one more piece of the puzzle. And that is that, technically speaking, the 3D printers are not like Rhino in that they don't recognize NURBS objects. We talked about the mathematically driven objects. 3D printers think of it as a polygon face, much like SketchUp, where you have the triangles that make up your face. So we're going to convert this over into a mesh before we leave. Now, we could do the conversion as we export the file to go, or we can do the mesh conversion before and see in preview, does it look the way we want it to do. So I would encourage you to do it ahead of time, which is what I'm going to do. If you select your object, there it is, we will just type mesh, which is essentially the command to convert to a mesh. I'll hit enter. And it gives this polygon mesh options count here. Depending on your building, you can choose fewer polygons or more polygons in terms of the number of ways it divides up into pieces. So for example, if I went up a little bit, excellent, thank you. Look at that, delivered. Here's the sample. It finished. It started at 7 this morning. Anyway, this one's a little bit more rigid than the one that I had last class. So I'll pass this around so you guys can see it. But it turns out pretty cool. Okay. It was the settings. I'm still messing around with what the actual settings are. If you look at this piece, you guys won't be able to see it until I pass it around. I will pass it around so you can see it. You can actually see the triangular faces on this object, which is what I'm doing right now. Okay? So I'm going to hand this around so you guys can see it. That's what we're going for. You can tell by how light it is that it's hollow inside. I mean, it has a little bit of structure to it. But anyway, I'm working out what the settings are over there, so hopefully it won't take 4.5 hours or whatever. It'll take less time. I'm working on it. Okay, you got to give me some credit. I'm trying. Okay, so right here under our polygon count, the more polygons, if I click preview, it'll give us kind of a preview of what this looks like. It's hard to see, but see all the little dividing lines there? If I do fewer polygons and I hit preview, they're going to be a little bit more spread out. We'll leave it kind of in the default middle range, and I'll go ahead and say OK. And I'll click off. And you can see that it divided up the surface into a bunch of little triangles. It did not delete my original file. my original poly surface. So I actually have to go in and delete that original. Likewise, I'll have to come down here and delete that original so that I'm back to the mesh file. So this is the mesh file that represents my object at this point. I like to do the conversion this way so that I can see what the count is going to be and do I like the accuracy of what's going to ultimately print. So there it is. Now that it's done, I'm going to select this object. It's ready to print. I'll select all of it, and I'll go to File, and then Export Selected, which we did before. And instead of picking AutoCAD from this list, we're looking for something called a .obj, or an object file. That's what we look for, .obj. I'll go ahead and choose where to save it. Let me make sure it goes in the right folder here. There we go. It's going to go in there. This is exercise 217. I'm going to go ahead and click on Save. We get some options here. All of the defaults are just fine. I'm going to go ahead and say OK at the bottom. And that's then going to write. Notice it brings up this again. I told you it would. We'll just say OK, that's fine. And it then wrote the file that we need to do the 3D print. So this is the Rhino manipulation of your object to get it ready to print. The actual printing process, where it goes from here, which I'll write out and I'll talk you guys through, essentially is you take that object file and you have to convert that into a set of computer instructions that tell the 3D printer how to move, where to go, and how much plastic to extrude. You will write that using a separate piece of software over in the other lab. So you'll come over with your object file, and then you'll write something that's called G-code. That is the computer instructions that tell the 3D printer where to go and how to extrude the material. Once you have the G-code file, which is a separate file you'll save, so you'll convert the object file into the G-code file. Then you'll load the G-code file into the 3D printer and essentially say print. And it'll sit over there for hours and do its little printing thing. Okay? So this is the skill set that you need to have a file that's ready to 3D print. And there'll be another skill set about actually setting up the printer and printing. I'm still working through the options for that to try to speed it up and figure out what's right. In my world, the best case is the shortest amount of time with a reasonable quality product at the end. So we're finding whatever that compromise is so that you guys don't have to sit there for hours and hours and hours. I'm still not quite sure how this is going to wrap into the grade for assignment 203 just yet, the 3D print part. That's because I still don't know how it's going to work for all of you to do the 3D printing part of it. So rest assured that everybody's going to be OK on that. If it ended up where not all of you can 3D print, it's not like you're going to fail that assignment. Does that make sense? So we're figuring that out. So bear with me on that. The renderings, however, are critical. The laser cut file with the red and blue lines is also critical as part of it. You will be graded on those for sure. And then we'll work on the 3D print piece of the puzzle. Okay? Are there any questions about these two parts or these two actions? Make sense where you're going? OK. Sounds good. I'll let you guys work. I want you to do the unrolled surface today. I want you to do the object file today. It does not have to be your final model for assignment 203. In fact, it probably won't be yet because you're probably still making changes to it. But ultimately, you're going to do both of these for your assignment 203, which is separate. Remember that the building is going to be a little bit taller. It's going to be 808 feet tall. So it's a little bit taller. It should be the proportions of the little building that I'm passing around. That's kind of the target of what we're going for. Like I said, I might have to shrink it to half the size. I don't want it to be too small of an object, though. I want you to get something good out of it. So I'm figuring it out at this point. Okay? Are there any other questions? Yeah.
The first example that you gave was kind of hard to match. If that is the case of our building, should we do a new one, very simple?
Today you can do a new one, very simple, just so you get the pieces sorted out. On that one that I was doing that was a little bit more complicated, ultimately I might have to just make the pieces as separate pieces with tabs on them such that I could glue them in. They might not work. Some of them might have worked. I stopped working on it because I didn't want you to sit and watch me do it. But essentially, you could cut them all separately with tabs and glue them together afterwards. Whenever you can do a fold, it's better because the fold matches up with the fold, and then you don't have to do a cut or a tab or glue or anything. So it depends a little bit on the complexity. I haven't had in the past too much trouble getting it to line up. This is one of the first ones that I've had trouble getting it to line up because of the twist and because of the folds on the sides of the building. Even the building that you were working on, I think would unroll just fine without overlaps. So most of the time you can lay it out without the overlaps if you think through kind of strategically where stuff goes. But if you have trouble, I'll sit with you and we'll go through it. All right?